How's everybody doing? Psyched about the midterm?
Not at all.
Super pumped?
Not at all.
How about groups? Groups doing okay?
What?
Groups? Good? Good? Hate each other? Tell the population in the room is starting to fluctuate back up as people get scared again. It's good. Welcome back, children. We missed you. All right, let's do this. Oh my God, that's loud. Hi, how's everybody doing? So today we are starting our investigation of user testing, usability testing, what it means to kind of move away from the kind of hand-wavy, yeah, I think people kind of like it, I think people have troubles here, sort of testing that we've been talking about so far, and into really more empirical, more quantitative, more kind of solid figures about what it means for a user interface to be good or bad. And so just as a reminder of where we kind of are in the big picture of our iterative design cycle, we've knocked off a bunch of stuff about design. We did brainstorming and task analysis and contextual inquiry. And we did all this work on kind of conceptual models and models of human behavior and learning about kind of how people interact with systems in theory. Then we blew really quickly through prototyping. And the reason we didn't linger too long on that is that more than anything is kind of what you guys as computer scientists do. Right? So you have some idea about how to go out there and build things. You're engineers, at least many of you are. And those of you who aren't engineers are kind of, cog-sci people with an engineering bent. So I think you have some notion about what it means to prototype. And then the other reason we kind of glossed over that so far is that we're going to be hammering on that in the project, in the group assignments. So more prototyping to come, but we've gotten the gist of that so far. And now, so far, all we've done in terms of evaluation is we've talked about how to run a paper prototyping session. But a paper prototyping session is, while representative of kind of a class of user studies, just kind of one small piece of the pie here. And so today we're going to dig into more qualitative evaluation in terms of kind of empirical qualitative evaluation, and then start getting into the quant work. And on Thursday, we will dig into like inferential statistics and talk about how you move from lots of data into conclusions about a product. Cool. Any questions on where we're positioned in the course while I drink my water? Grand. So we're going to start off by talking about usability testing methods and sort of the different genres of testing that come up in human-computer interaction and in the sort of design world in general. So here are a few of those genres. We have automated testing, which is about finding usability metrics that are automatically computed by software. Inspection methods based on experienced evaluators. Formal evaluation based on models and formulas. And empirical evaluation, which is what we're talking about today, usability assessed by testing with real users. What have we seen so far? Which of these genres have we covered, and with what methods? Yep. Okay, so heuristic evaluation is a usability inspection method that's into this bucket. Yep.
Using model processor is automated.
Okay, not necessarily, although it could inform automated, but it's definitely in this like formal evaluation bucket. So model human processor and GOMS and Fitts law and things like that all fit into this formal evaluation thing. Anything else? We haven't really talked yet about any automated usability methods, but can anybody think of one off the top of their head? Yep.
Load times.
What's that?
Load times.
Yeah, so things like paths through a UI or logging, times at different places on a web page, or strictly monitoring things like load times, all fit into this kind of automated usability assessment bucket. Cool. So the reason that we've waited until now to talk about empirical testing is that empirical testing is by far the most expensive of the kind of usability methods available to you. Expensive in a few dimensions. Expensive, one, because you have to have a trained usability analyst, user researcher sort of person around to do these sorts of studies. Big companies keep staffs of user researchers and user analysts, but startups and people kind of the size of Canoma don't. And so you have like one person like me who does that and a lot of other things. You normally have to pay your participants. And depending on how you get your participants, that can be either moderately expensive or like insanely expensive. So how much would you guess? There are companies out there that will recruit participants for you. If you've ever been to like the mall, or I don't think there are malls anymore. If you've ever been to like a place where somebody stands out there with a clipboard and is like, hey, I'll pay you to like come in here and be a part of this focus group, or come in here and like hit these buttons, they'll pay you some small amount of money, like $50 or something. How much do you think the company that cares about the data is paying them per person? Any guess? I just took bids on this recently from many companies, so I have a very good idea of what people, at least in the Valley, are charging right now. It's about $1,500 per participant to recruit participants for a user study through companies like, I won't name them, but through the big companies down around the Valley that recruit people. So if you want to run 20 participants, you could easily be talking about $40,000 between kind of recruiting fees and running the study and paying the people and everything else. It takes a lot of time. Whoever you've got involved in running the study, it's not quick. And so anyway, at the end of the day, user tests, even very small scale ones, can easily cost several tens of thousands of dollars, which is real money if you're a startup and you're out there getting going on something. Which is why we've talked about all these kind of discount usability techniques over time. The advantages being that they are cheap, you don't need any kind of special labs or equipment, and that if you're very careful with it, if you invest more time in it, you get better results back from it, which is not necessarily true of a user study. Like user studies are very finicky in terms of you have to get your experimental design right to get like meaningful data back. Very fast. You can spend a day doing a heuristic evaluation instead of like 2 to 4 weeks doing like a basic user study. And then it's also very easy to actually do. Like most of the people in this class, I would consider competent to run a heuristic evaluation at this point, whereas most of you in this class, I would not yet consider kind of competent to go out and do like a full-scale user study. And so there's just a serious difference in training in terms of what it takes to get ready to do these things. So what are the discount usability techniques? Things like heuristic evaluation, where you use a predetermined list of criteria. And then I also want to talk about one more big one today, which is cognitive walkthroughs. So in this, it's like a heuristic evaluation, except without the heuristics, if that makes any sense. But basically what you do is you, as the like usability expert professional person, sit down and walk through a user interface, and you're given a set of tasks by whoever designed the interface, just as a user study participant would be given a set of tasks. And you basically sit down and you just go through every screen of the interface trying to complete that task and noting at every juncture, like what is the cognitive load of making the next step? Can I tell by what I'm reading on this page where to click next? Is there any ambiguity about how to accomplish what I'm trying to accomplish? And it's very much like kind of a code walkthrough. It's one of these kind of collaborative engineering techniques for deconstructing a complicated artifact and then going through and learning about it piece by piece and marking down, critical incidents that you think users will experience. And so really fundamentally, there's this progression from like heuristic evaluation where you're looking at a artifact in terms of these rules of thumb, but not necessarily in terms of how the user will actually use it. You're just kind of stepping through every single piece in an abstract way, to cognitive walkthroughs, which are about pretending you're a user and tracking how things go, through to qualitative user studies that we'll talk about next, which are doing the exact same thing with actual users. And then these other like halfway between real user studies and cognitive walkthrough techniques are starting to really take over the world right now. So online remote experiments, things like Mechanical Turk. People know what Turk is? Yes, cool, okay. So Mechanical Turk is this system where you pay people very, very small amounts of money to complete some task. And often they're Fitz-lawing sorts of things in the early days. Nowadays, there's a lot of expansion in kind of the types of things you can do with kind of crowdsourced development, but comes with that a lot of ethical concerns that we'll talk about a little bit later. Anyway, so there's that, and then there's all the way through to like massive, large-scale A/B testing, where you have millions of people looking at version A of a site and millions of people looking at version B, and you're pulling automated data about what is more effective or whatever your metric of effectiveness is. Cool, there's that. All right, so qualitative assessment, we're not going to talk about too long because it's fairly straightforward, but the idea is that this is kind of what we've been doing so far. It's the method of going out and just kind of talking to people, showing them the user interface, giving them some tasks, and letting them walk their way through it. So contextual inquiry, for instance, is a type of qualitative method. It's a formative evaluation method where you're going out in the world and you're kind of learning about the needs of your user more so than learning about your artifact itself. Usability studies are where you sit down and you have people do the same tasks that you would do on a cognitive walkthrough, but you are just watching them like a hawk, figuring out what they're having trouble with, where the critical incidents are, what they struggle with. Qualitative methods help us understand what's going on in the system. They help us look for usability problems, and they help you kind of roughly evaluate usability of a user interface, of whatever your design is. And so the broad steps to running a qualitative study are to define your tasks. So this is the same thing that you guys did in your task analysis process. Like I said, those will keep chasing you all through this process. So you define some tasks, you recruit some participants, you ask the participants to complete those tasks using the user interface while thinking aloud. And this is it's called a cognitive walkthrough or a cognitive apprenticeship. And it's a method that comes out of social psychology and education that is all about just keeping the person talking and narrating what they're doing. So it's very much trying to force them into this now I'm looking at the screen and I'm reading the second line and I'm reading the third line, and I think maybe if I click on the fourth line, something good will happen. And now I'm going to click up here on the X because I want to leave. And just keeping the person talking. And it's really super unnatural for people. So it's very much on the kind of person running the experiment, running the user study, to keep people in that frame of mind where they just blab and blab and blab about what they're looking at. When you do these sorts of user studies, the instinct of everybody, one, is to not talk enough, and two, is to hide whatever they're doing on their device, keep it out of your sight. Your job is to be all up in their business, and not only all up in their business, but all up in their brain, because you want them to keep talking about every little thing they're seeing. So then you note critical incidents, what went well, what went wrong, you audio record for quotes, and above all else, you don't help the user and you don't let them get all introverted and sad. You just keep them talking and keep them working on whatever they're doing. The output of a qualitative usability study is generally a usability report. And in form, this is very similar to the output from a heuristic evaluation. So it starts usually with like a methodology and participant demographics section, just to kind of inform your audience, who will usually be designers or engineers or marketing or sales or somebody else in the organization, kind of how you ran the study and who participated in it. Usually you do a bunch of kind of general reactions from users first. So whatever little quantitative measures you have, if you gave people like surveys and Likert scales, you get it in there. Broad thoughts, like most people hated it. Most people liked it. Many people said they would buy it. People liked this part but not this part, things like that. And then you try to break down very specific positive and negative comments, usually using exact quotes from audio recordings, just to really drive home the point that this is empirical. Because when designers and especially engineers aren't used to this method, they see the usability analyst as like an alien who's just like landed all up in their territory and is trying to tell them from on high like what to do. And if you don't want to give that impression, the best way to avoid it is to really frame things in terms of like, participant 3 says X, participant 5 says Y, and they struggled for these reasons, and here's how I found this out. So it's not you, the usability expert, harping on this thing or telling them that the UI sucks. It's the participant, right? And then finally, you go through and you list usability issues with severity ratings and categories and pictures and video and whatever else you have to describe it. And that part is very much like the thing you already did for the heuristic evaluation assignment, where you say, like, here at this spot in the interface, people got stuck. Here's why I think they got stuck. Maybe here's a suggestion for fixing it, depending on kind of the context that you're working in. The interesting thing about qualitative studies is while they're not what you talk about the most in HCI, they actually are, I think at this point, mostly what's being done in industry. It's certainly all that I do. I never run like full-on quant studies as a like industry practitioner sort of person. And most people don't. I think most people just care about like finding usability issues in their own products and aren't necessarily trying to make like the next model human processor paper. And so they don't really care whether this is science or not, which it's not. You know, it's very useful, but what it is definitely not is science. Make sense? All right, so for the rest of this lecture, we're going to talk science. And science in HCI is done through quantitative user studies. And these are, you know, reliable, repeatable measures of how a user interface behaves, some aspect of the UI. They can be used to compare two or more designs on some measurable aspect of it. And ultimately, these are designed to kind of contribute to the broader theory of human-computer interaction. So if you want to make the next model human processor, you want to come up with the next Fitts law, this is how you get started. You start by doing quantitative user studies to figure things out about the world. And broadly, you kind of collect and analyze all the user events that happen while somebody is working through a user interface or completing some tasks. And you record everything that you can. So some examples of things to record are like time to complete a task, average number of errors on the task, users' rating of an interface, perception and satisfaction. And you can argue quite reasonably, I think, that kind of the user's perception of what is optimal is more interesting in many cases than the actual like speed figures. If you were to find yourself in like an A/B test and interface A was 10% faster, but interface B was perceived as 10% faster, that would be an argument for interface B, I would suggest. Cool. So just to compare the two very quickly, one, more than anything, don't think of this as a like progression. It's not that like qualitative studies are good, quantitative studies are better. It's that they are used to solve different problems. And so qualitative studies are faster, they're less expensive, they are particularly useful in the early stages of the design cycle, And out in the real world, they're often all that you do. That's just the case. Quantitative studies are reliable and repeatable, ideally. They are kind of employing the scientific method in the pursuit of some truth about the world with respect to your user interface. And the best studies, the ones that really kick ass, are able to produce generalizable results. So why do we care about generalizability? What does that even mean? What does it matter to us if a result is generalizable? Sure.
So like in the reading, for example, if you go through an entire experiment and the results or the experience itself is not generalizable, then it's only going to be applicable to a certain set of conditions or control variables, and it's very much pointless.
Yeah. So the concern is that other thoughts, I suppose. No. Yes. So the concern is that you're going to learn something that is just too narrow to be broadly useful. And so if you, say, ran a user study with 3 19-year-old women from the same town and did your user study of some interface with that audience, and then you want to go back to your employer and say, like, yeah, I'm pretty sure that these findings from these 3 people will apply to everybody in the world. Like, don't worry about it, it's cool. You have some sort of generalizability problem there, where you're perhaps being misleading to your audience about how applicable your results are to a general audience. And so I would argue that even in the qualitative studies world, you're shooting for generalizability. Even though the outcome is more like a specific case study, you still want to get a representative audience in and learn things about how your UI works in the world. But if you're really good, you do quantitative studies that will then eventually lead to something like the model human processor paper. So for instance, all of those like little times in the model human processor paper where the cognitive processor takes X milliseconds and whatever, those came from lots and lots and lots and lots and lots of social psych, HCI style quantitative user studies. And getting that data let these people tell us some truth about the world that they wouldn't have otherwise. All right, and so after the midterm, the next group assignment is going to be a pilot user study. And the idea here is that you're going to go out in the world with your low fidelity prototype, whether it's a paper prototype or a balsamic prototype or an Illustrator prototype or whatever it is that you're building. And you're going to conduct a qualitative study with it. We're going to do that primarily because we don't have kind of the time or the available subjects to run like a real quantitative study. Like, I can't ask you to go have 100 people use your thing and time them all. But I can reasonably ask you to go out and do a qualitative study, and then on top of that, do just a little bit of kind of light quantitative analysis. So as you're building your UI and you're thinking about your tasks and you're doing the whole low fidelity thing, be thinking about what you could measure in terms of using the interface. I will tell you that most of it will be kind of search time, how long it takes for somebody to figure out the next thing to do in the UI. But that's something that at least that you can measure. And then you'll be computing some very basic statistics. And you'll have to think about kind of variable control and everything else that we talk about in the rest of this lecture. Cool? It's going to be fun. All right. Things that are out right now. So low fidelity prototype video is due 3/6, which is Friday. Okay, do that. Any questions on the low fidelity prototype video? It'll be fun. There's lots of ways to do this. The main goal is just to kind of show us that you're making progress towards like a real design out of your kind of high level concept. Midterm is the 12th, next Thursday. We will have a review session here on Tuesday that the GSIs are going to run. Covers lectures 1 through 14. 14 is this Thursday's lecture. And the way I want you to think of the midterm, for what it's worth, is don't think of it like a midterm. Think of it like a final for this half of the class. Because we don't have a final. And we've covered, as of Thursday's lecture, everything that I consider to be kind of the core material. Be like things that you must know if you're coming into my office and applying for like a junior UX sort of position. And so this is a final over that material. And then the second half of the class is a topics course and more fun and interesting and wacky and your final project. And then anyway, when we come back after the midterm, that next week will be the low fidelity user test. So that will be the last assignment due before spring break. Then spring break, woo, and then other things continue after that. Cool? All right, so we're gonna dig into the sort of nitty-gritty details of experimental design now. What fun. So this is kind of based on your reading and based on a number of other things. But we're going to go through one by one all of these steps for experimental design, how to build like a real controlled quantitative experiment. And the steps are roughly these: make a hypothesis, identify your variables, come up with a protocol, get some people, don't forget to talk to the IRB, run pilot studies, run your experiment, do some stats, draw conclusions. And so today we're going to get through 7, and then Thursday we're going to talk about 8 and 9. So experimental design, the first step is to come up with a hypothesis. Who can give me a like short working definition of what a hypothesis is? 4th grade science fair is coming back to haunt you. Yep.
Conjecture as to why you believe an observation is correct.
Okay, so a conjecture about why you believe something to be true, or why you believe that an observation is correct. In theory, you don't have an observation yet because you're hypothesizing before you go and observe anything. But I'll buy the conjecture part. Yep.
It's just an idea you want to test out.
Okay, so it's an idea you want to test. True. And more specifically, it's kind of a claim about the world, a claim about the universe that you want to test. So hypotheses take the form of kind of declarative sentences. You know, X is true. It is the case that we will see Y. They are not questions like, what will happen? That's not a hypothesis. And so it's just something that you can like specifically test. And it's a precise statement of kind of what your expected outcome is when you run an experiment. Independent variables, or what are often in the social psych world called factors, are the attributes that we are manipulating, what we're varying in each condition of an experiment. And then the levels are kind of the range of independent values. So just as an example, say I have a hypothesis, and my hypothesis is warmer temperatures in this room lead to more sleepy students. That's a lucid, testable hypothesis. And in that case, our independent variable would be something like the temperature in the room. You know, I could set it to be 60 in here, or I could set it to be 80 in here, and that would be exploring, you know, various levels of a single independent variable. And then the dependent variable, the response variable, what we're trying to measure would be sleepiness. How you would measure that, you have to be in my position. I can very easily measure sleepiness in this room. And usually in HCI studies, we're measuring, you know, kind of user performance, how well people do using an interface. Notably, these independent variables could be levels, or they could be complete differences. So it could be that you have like interface A and interface B that are completely different, and you know, you're testing those two things. So yeah, we could vary the room, for instance, that you're sitting in addition to the temperature of the room, to see if we can figure out if the room itself has anything to do with it. Control variables are the attributes of the experiment that will be fixed. And so what you're trying to do here is to get rid of confounds. You're trying to get rid of attributes that are varying amongst your population and that may be causing the changes in the dependent variable that you haven't properly accounted for, that you didn't, you know, get down in your spreadsheet and try to figure out. So you're trying to get rid of as many of those as possible. You don't want to get in this case where you have some other random crap, you know, causing your change in the dependent variable instead of the thing that you're actually varying. And then another way that we control experiments is through what we call random variables. And these are attributes that are randomly sampled and are tend to increase the generalizability of a study. So what's an example of a random variable? Say I had 2 rooms of you folk, and one of them was going to be my control. We leave it at this temperature. And the other was going to be my experimental group, where I crank up the temperature to 90 degrees. What would be some random variables? Yep.
How much sleep someone got the night before?
Okay, so that might be important, but we're hoping that that just works itself out in the population, and so the 2 rooms will be equivalent. Yep.
Whether the person commuted from class or not.
Okay, so how they got here.
Incidences of narcolepsy.
Incidences of narcolepsy. We would hope, although that's one of those ones that you might want to actually control for. So you can take what you're hoping is a random variable and still ask people, because that may be so rare that you only get 1 and it's only in 1 population. Okay, so you can ask about that sort of thing. What else? Yep.
Ambient conversations.
Okay, so kind of what's going on in the room, the things you're not controlling there. Makes sense. You've said lots of good things, but none of the canonical HCI things. Yep.
The subject of the lecture.
Okay, that you would probably give the same in both, right? So you would control that, ideally. Come on, people. There's big random variables. Yep.
How much clothing people are wearing.
I like it, but no.
Like age group.
There you go. Demographics. So the big random variables are demographics. They're age and gender and handedness and personality and optimist, pessimist, and things like that kind of are the broad demographic categories. That's the sort of thing that you just kind of expect to come out in the wash when you design an experiment and randomly assign people to groups. Okay, if we're talking about variables, we have to talk at least a little bit about type, unless you're using JavaScript. Oh, that was a joke. So we have kind of 3 big types of variables when we're talking about experimental design: nominal, ordinal, and continuous. So nominal are categories, ordinal are things that have an order, and continuous are intervals. Give me some examples. What's a nominal variable? Yep.
Gender.
Okay. What else? Yep.
Types of fruits.
Okay. Yes, fruit is indeed nominal.
Occupation.
Occupation. Okay.
Like ethnicity or race.
Okay. All good nominal variables, things that are kind of, there's no ordering. It doesn't make sense to take, banana minus apple and try to talk about that. So that's the continuous part of it. And there's no ordering unless you just really strongly feel about apples and oranges. How about a continuous variable? Yep.
Age.
Age. Sure. Temperature, just things you measure, time, anything that you can kind of measure and it means something to subtract them from each other is a continuous variable. And how about ordinal? Ordinal variables? There's a big one in HCI. Yep.
Education level.
Sure. I'll buy that. There's something intriguing about PhD minus bachelor's, but I don't really know what that evaluates to. Yep.
No, I was gonna say rating.
Okay, so that's the big one, is ratings of things like user satisfaction. So when you have the on a scale of 1 to 5, how do you feel about life? 3-ish. That's very much an ordinal value. While we often will fudge the numbers and subtract these things, it's not really correct. You're fudging your statistics when you do that. Cool. All right, so common metrics in HCI are things like task success, which is very nominal, like either you succeeded or you failed. Task completion time, which is continuous. Errors, which is continuous. Efficiency, learnability. And then you get into these like ordinal satisfaction metrics, which are self-reports on like ease of use and frustration and things like that. Time on task is super common as a metric. Learnability is doing the same task many times in a row and seeing if people get better at it. And usually they should. Like either your UI was like super usable or super unusable if you don't see any learnability in there. Cool. And so on the satisfaction metric, we often see these Likert scales if you're pronouncing it correctly. And here is a place where the respondents rate their level of agreement to a statement. So you throw something out there like, overall, I'm satisfied with the ease of completing the tasks in this scenario. And then you ask them to strongly agree, disagree, neutral, agree, strongly agree. And these things, one, are ordinal. So you're really not supposed to take averages of them. You know, if you have 40 people do a Likert scale, you're not supposed to average it all together. Although you can take the median of it, which is what you're really supposed to do when you're doing these sorts of work. And then there's much disagreement in the HCI community about whether these things should be 3-point or 5-point or 4-point or 8-point. Let's compare just 5 versus 6, which seem to be the most common things at this point. What do you think is a pro or con of a 5-point Likert scale versus a 6-point? Yep.
6 points makes you choose a side. You can't always be neutral.
Indeed. So what you will find is that if you give this thing, the mode is always 3. Like always 3. No matter what you're testing, it's always 3 because everybody's neutral. And so maybe you'll see some effect drifting to one way or the other, but the mode and the median are basically always 3. If you do a 6-point Likert scale, then all of a sudden, instead of being like the mode being 3, the mode will be like 6. And it's crazy. Like people, when not given a neutral option, tend to float to the extremes. So either they want to be neutral or they want it to be binary. And it's very, very confusing from the perspective of data analysis. Like, what does it mean to take an average over this thing when there's like so much human psychology bullshit going on in terms of how people interpret these scales? So anytime you see one of these in a user test, be suspicious. And if you want to be friendly to like the user researchers out in the world, pick lots of like 2s and 5s and things, because those are the responses that they're never getting from the general population. So anyway, we'll talk a little bit about how you process data from these things into something meaningful on Thursday. So I want to go through one concrete example real quick, and we're going to watch this brief little video. Maybe, quite possibly, we're going to watch this video.
In this video, we present the bubble cursor, a dynamically sized area cursor which can enhance selection in both dense and sparse target environments. The bubble cursor continuously grows and shrinks such that there is always exactly one target within its boundaries. There are 2 main problems in standard area cursors which we address in the design of the bubble cursor. Area cursors are generally square or rectangular, which means a target that is further away from the cursor location can be selected before a target which is closer. We use a circular area cursor, so that the closest target will always be selected first. The second problem is the size of the cursor. If too large, multiple targets will be in its bounds. If too small, the area cursor may not capture any targets. Our solution is to continuously update the size of the cursor so that there is always exactly one target within its bounds. To calculate the radius of the cursor, we consider...
Okay, so that's exciting. This was a famous experiment that they did very well. This paper is very well known. So what would be a reasonable hypothesis if you were to run a user study about the bubble cursor? Hit me with the hypothesis, please. Okay, so that's a perfectly reasonable hypothesis. that users will acquire targets faster with the bubble cursor. That is, their movement time will be lower. Okay. How about another hypothesis?
The users can hit the targets they're looking for more accurately.
Okay, so that there will be fewer errors is another reasonable hypothesis. Those are the two that I've got here. Independent variables. What might we be varying in an experiment to learn about the bubble cursor? Yep.
Density and frequency of targets.
Okay, so there's a possibility that we're changing density or frequency of targets. That would be an experimental design. I would suggest that in this experiment, we're going to fix those. So those are going to be controlled. Given that new knowledge, what would be an independent variable here? Yep.
Yes, we need the regular cursor.
Yeah, so an experiment you could design here would be an A/B test between your bubble cursor and like a regular old mouse. And so cursor type could be our independent variable, but you're right that other independent variables could be like target distance, target width, density, things like that. Dependent variable, what are we going to measure? Yep. Speed and errors. It better relate to our hypothesis, right? So for hypothesis 1, we're going to measure speed, and for hypothesis 2, we're going to measure kind of error rate. Make sense? And might as well throw in user satisfaction because we always throw in user satisfaction. So put some Likert scales on there and watch the numbers make no sense. Wonderful. Control variables. What do we want to control between conditions? Yep.
Mouse type.
Okay, that's a very good one. So if you had one person doing this with like the Kinect and one person doing it with a mouse, your study would be obvious nonsense. Okay, so let's control the input device. What else we got? Yep.
Like maybe the layout of the chart of the icons, or like have them on the same screen.
Yeah, so you could imagine having like the exact same layout of targets and even the exact same ordering of targets, all plausible. Color scheme, screen size, things like that. And then what will our random variables be? Yeah, so age and all the other demographic stuff, gender, handedness. All should hopefully come out in the wash here. Cool. And the goal of any user study is to get these two types of validity, internal and external. Internal validity is the notion that you really are confident that manipulating the independent variables results in a change in the dependent variables. External validity is a belief that your results are generalizable to other experimental settings. And so this is just about careful experimental design, and this is about careful kind of problem space selection and making sure that your target population really makes sense in the rest of the world. And then you use statistics to kind of get confidence in your results. So a little more about kind of experimental protocol. We're going to talk about task design and condition design. So number of conditions is a big factor in how you kind of run an experiment. So if you, in our bubble cursor example, you have kind of one thing that you're going to vary. You're going to do bubble cursor versus mouse cursor. That is a very kind of straightforward study to run. There's two conditions. You could either do it between or within subjects. Not so bad. If you instead start varying the distance around the cursor and you start varying the size of the target as part of your independent variable design, you could suddenly end up with like a massive number of conditions where each participant is going to have to do each one of these things if it's a within subjects design. And so this can blow out of hand really quickly. If each one of these conditions takes 3 seconds, which might be the case in the bubble cursor thing where you're trying to pick the targets, not such a big deal. Like you could live with that. If each one of these things, like say for my PhD dissertation when I was doing this, is a like 6 to 12 hour user study, then this is going to be miserable. Like you're never going to get anybody to come in and do 24 conditions at 12 hours a piece. And so you really have to think carefully about like, do I need all of these factors, or what could I do to like trim them down? What you should know for purposes of this course is just that this can get out of hand. Like you need to trim factors. So one way to reduce the number of conditions is to vary only one independent variable at a time. So in the bubble cursor example, it would be just doing A versus B while leaving the rest of the task intact. What could be a problem with that, though? If you just do that and then say you just do the size of the targets and then you just do the distance. Yep. Okay, so you've made the test less real, which means that you're hurting the generalizability to some extent. What else? Yep.
There could be conditions where you need both of those to get negative results.
Yeah, so you're missing the effect of interactions. So it may be that bubble cursor and big targets behaves very differently than one might predict if all you know is about bubble cursor and all you know is about big targets. And so you really do kind of have to explore this whole space if you want to get all these interaction effects. So there are a lot of things you can do to kind of mitigate this problem. One is to kind of pick a couple independent variables at a time and then see if something interesting is happening. And if nothing interesting seems to be happening, just pick a fixed control value for it and move on. And then there's this crazy factorial design process for choosing each of the subsets of independent variables to vary. And I will leave that as an exercise for you to go learn about. But basically, it's a formal method for choosing which variables to study at one time. All right, a little bit about subjects. You want to, for our purposes in usability testing, pick a population that as well as possible reflects the intended actual user population. So the right balance of novices and experts and the right mix of age groups and the right mix of genders. Don't just test with whoever lives on your floor. Do dorms have like gendered floors still? Some. We had gendered wings. So anyway, if you go and you pick 12 non-colorblind right-handed adults, male and female, you have controlled for handedness, you've controlled for color blindness, and you've let randomness take care of like gender balance, things like that. Population group could be purposefully purposely varied, or it could be controlled. So you could say, I'm going to run this all with 20 to 25-year-olds. What's the disadvantage of controlling your population too carefully? Yeah, you're just hurting your generalizability, basically. All right, so between versus within subjects design. Between subjects design is when you bring in groups of people and they all use just one interface, and then like the other group of people uses the other interface. So if you recruit 4 people, maybe person 1 does A, person 2 does B, person 3 does A, person 4 does B. Whereas within subjects design is when everybody uses both. So persons 1 through 4 use both A and B. What are some pluses and minuses that you can imagine of within versus between subjects design? This side of the room has been very quiet today. What do you got this side of the room? I'm just going to start calling on people. I know your names. Miriam, give me something good here. What are the advantages or disadvantages of between or within subjects design? We have 2 sort of broad ways we could design an experiment here. They have pros and cons. Give me one.
One is more realistic.
I'm not buying that. Nope. Yep.
Between subject variability, it gives you the between group variability, so you know how different your experimental groups are. And within group gives you the variability between your subjects within one constraint.
Okay. So you get kind of a different view of the world based on the 2. Yep.
Within subjects, you might take longer.
Okay, so that's an obvious one. Within subjects design, it just takes a hell of a lot longer per participant because they have to do twice as much stuff. Yep.
in general, you have to be careful about how you do it, just to make sure like the order doesn't matter. Or,
Okay.
that, like the groups aren't different.
So you can get all sorts of like wacky learning effects on within subjects designs, and in between subjects designs, you could accidentally create two very different populations. Yep.
Within subject designs, there's a lot of error in terms of random variables because they're different time periods, so you don't need to like factor in a lot of other things that could potentially affect results if you look at someone like 10 years down the road.
Okay, true. Yes, if these two events are spread out meaningfully in time, then it could yield very different results. Yep.
You need twice as many people for between subject design.
Okay, so you got to recruit twice as many people. That never sounds good when I have to pay for each one of them.
Within subject design, you have to control for less other stuff because a lot of things are controlled for because everybody did everything.
Okay, so you fix a lot of variables by having the same people use both interfaces.
I feel like within subject design, using one interface might influence the other interface.
Okay, so this is this learnability thing where the order matters. There's one more big one that you've missed, like the reason you do within subjects designs. Yep.
I think like between subjects, you have to make sure that your users are similar enough to make sure that your results are from the difference of interfaces.
Yep. Okay, so you have to control your populations carefully on between subjects with design. Give me the big within subjects reason.
You're already controlling for like the same person.
Okay, one more bigger reason that you do this. Nobody?
You can have people tell you which they like.
There you go. So that's the big one for within subjects design, is that you can ask people, did you like A or did you like B? And you can measure for an individual, like, did they do better with A or did they do better with B? But like the big reason you do within subjects design is just so that you can ask them that question, which was better?
Is within subjects basically like A/B testing?
Basically, although A/B testing can mean many things. So there are between subject A/B testing methodologies also. So if you get like enough people using A and enough people using B, then you can do a within or a between subjects A/B test also. All right, so I think we got most of this. Yeah, I'm pretty happy about that. The big one here is this ordering effect thing. And so to talk just a tiny bit about ordering effects, you do have to care about who sees what in what order when you're doing a within subjects design. And so what you usually do is you turn it into a random variable. You either randomize the order of the conditions across subjects, or you purposely counterbalance it, or you do all other sorts of kind of clever counterbalancing methods. Just to say one word about counterbalancing, this is when you take a random variable and you just like force it to be random. So if you have, 10 left-handed participants and 10 right-handed participants in your study, you just split them evenly between the two populations, 5 and 5, instead of hoping that randomness takes care of that for you. So that's a counterbalanced variable. Yep.
Wait, go back to that previous point. I thought A/B testing was where you had two separate groups. not-
Can be either. So forget what I said very briefly about it being more a between than a within subjects thing. It's either. So A/B testing just implies that you have two interfaces and you're testing them. Like that's all that means. So it can be either. All right, the last little bit about this that I want to talk about is, how do I have 20 slides on? Is actually going out and running the study. So first things first, always go out and pilot your experiment. And this is a big deal because you end up just wasting everybody's time if you don't go out and do your pilots, right? So usually you pilot a user study with like lab mates or classmates or friends or family, somebody whose data you wouldn't want because their data might be biased in various ways. So you don't mind that you're kind of burning them early in the process. You don't necessarily have to pay them. And you can go out and find out what problems you have in your study before you start running like the real study. And the big issue here is that you can't easily change your experiment's design after you've started the experiment because you may be screwing up your data, right? So if you collected 100 samples within one condition, and then you go out and you collect 100 samples under some different condition, you're not really running one study anymore. You're running kind of two disjoint studies. So always be careful to follow the same steps, use a checklist or take notes, and just kind of know what the process is for going through your user study. Get consent from subjects, which we'll talk about a little bit more in a second, and then always kind of go through a process of debriefing your participants and tell them, like, kind of what you were looking for and what you hope to learn from the study and things like that. Just kind of, the goal is to make people feel like they're on your team, not that you're just poking at them as lab rats, but that they're involved in the process of research. And towards that subject, I'm going to use the rest of this lecture to rant about research ethics. So there's a lot going on out in the world in terms of kind of how HCI and how social psychology are grappling with issues of ethics in research and issues of, how to make people feel good about their participation in user studies. And so from a high level in HCI, what we really care about is that our participants don't feel distressed, don't feel hurt, don't feel wounded by their participation in the study. And it really can be surprisingly distressing to come in and take a user study, even if it's just something as simple as like the bubble cursor. Like, people freak. People have like the weirdest anxiety issues around these things, and I get it. It's like you're dragging them into a lab and you're watching over their shoulder and you're saying, perform! And then you're taking notes and you're judging them, and they know that there's a reason that you care about this, and probably you want them to do better on one condition than the other, and you're going to be hurt if they don't do the right thing, and maybe you're not going to graduate, and maybe you're not going to get funding. And so there's this whole world of like stress crushing down on your participants, and it can lead to these like panic attacks and pressure to perform and feelings of inadequacy and fear that you're going to look like a fool in front of everybody else, or that your participation will be revealed to the rest of the world. And these are all problems. Like, we don't want our participants like freaking out. We want our participants being like calm and collected and happy and glad to be engaged in science. And so more than anything else, you just need to be respectful to your participants and kind of treat them the way that you would want to be treated. We have a formalization of that in the sort of social psych world that came out in the 50s, 60s, called the Belmont Report, which was a list of recommendations to researchers on kind of what are appropriate and inappropriate actions to take with participants. And I will warn you, if you're sitting here in this room, this slide is maybe what I consider the most important thing in this entire course, is getting this shit right. So above all else, respect for people coming into your user studies is how we do our business and how you are kind of ethically charged to go out in the world and conduct yourself. Having been through my course, I will find you if you go out into the world and screw these things up. And above all else, having a meaningful consent process is how you have respect for people, kind of telling people that they are engaging in a user study and that you are going to be monitoring them, that you're going to be kind of measuring things about their performance, and that you are doing science and explaining kind of why you're doing science, telling them all the information that they need to go out in the world and feel like they've participated in this study in a meaningful way. And then to let prospective subjects freely choose whether to participate or not participate. And that's a big one that people are screwing up more and more these days. This notion that if you are part of a research study, like, it is your right not to be part of a research study, and it is your right to quit a research study at any point. And that's true whether it's a 20-minute study in a lab or whether it's a 7-year longitudinal online study. Like, people are supposed to know that they're involved and supposed to be able to opt out. Very important. Beneficence is an antiquated word, but now you know an antiquated word, beneficence. And the notion here is that you are minimizing the risk of harms to subjects while maximizing the potential benefits. And where this rule comes from is that there were lots of horrible experiments done in the kind of World War II era on kind of populations that didn't have a whole lot of say in their lives. And so an example of like beneficence and justice here is, so justice, just so we can talk about all these at once, is about using fair procedures to select subjects and balancing benefits and burdens. And so it would be wrong, for instance, to go out and do a user study that causes a great deal of pain to one population for the benefit of a different population. And there was a lot of that going on in World War II. It would be wrong to go out and do a user study that you're doing just kind of for fun, but that kills people, you know, on the extreme end of things. There's a lot of that going on in World War II. These sorts of studies aren't common anymore, but the reason they aren't common anymore is because we've like clamped down on this crap. And so to ensure adherence to these principles, now schools, like research institutions and kind of any federally funded research institutions, generally have what's called an institutional review board. And anytime you want to do a like real user study, you go to the institutional review board and you kind of make your case. You submit what's called a protocol. That is how you're going to run your study. And they look it over and they say like, yeah, that's fine, no problem. Or they say, well, this is terrible. Like, we can't have you out there shocking people. You know, we're going to say no. But the point of the story is that it's not your decision to make. It's somebody external to your research who gets to carefully review what you're planning on doing and decide whether or not to allow you to run your study. So how you treat subjects with respect is about following your human subjects protocol. It's about keeping individual test results confidential. So you don't want to disclose performance on a test out to the world. Letting people stop whenever they want to. People are aware if you're recording them and allowed to stop the recording if they want. Knowing that their performance on the user test will not lead to them getting fired or lead to them getting a better job. Knowing that records will be made anonymous before you publish them. One major issue that people don't always follow is that often just participating in a study is enough information to hurt somebody. So say you're running a study on, the classic is you're running a study, and to be a participant in the study, you have to be HIV positive. And so you come into the lab and you acknowledge on your screener that you're HIV positive, and then you take the user study. Like, just disclosing that that person was in the user study could be a burden on the person. So that is considered confidential information that you were a participant in a study, period. Standardized consent forms are a very good thing. So Berkeley has a kind of standardized consent form where you go down the list and you say, like, I'm going to be recording you. This is what I'm using the information for. This is what we're capturing. This is how it's going to benefit society. This is how I'm going to pay you for your time, that sort of thing. By the way, that's another big one that comes under justice here, is that you're not supposed to pay people an undue amount to coerce them into participating in a user study. So imagine you have a potentially dangerous user study. You don't want to pay so much money there that somebody feels like it's going to like change their life to participate in your dangerous user study. Okay, don't waste users' time. That's kind of a basic value, but have everything ready before people show up. Don't make them just sit around. Use pilot tests. Take whatever steps you can to make users comfortable. Put them in a relaxed atmosphere, allow for breaks, pace things appropriately, and always just be willing to stop if people want to stop. So in BID, over in the Berkeley Institute of Design, we have a lot of studies on stress, where you intentionally put people into stressful situations and then monitor how that affects their computer usage. That's the sort of study that you want people to be able to bail on if they're like about to have a panic attack. Yep.
So how do you make sense of sort of like observing people, or say like your user studies, like looking at people's Facebook profiles or something, and they don't know that they're in it?
Say that was true. Yeah, so I tend to try to avoid those types of studies. It's not a privilege that everyone has to be able to avoid conducting those sorts of studies. But as a general rule, so if you, I'll put a link up here in a minute to the like UC Berkeley approved course on human subjects. Generally, anything that is considered public information is acceptable to monitor as long as you're not manipulating it. So as long as there's no intervention, it's acceptable to look at public information. So you can sit in the park and like count how many people are playing Frisbee. Like that's perfectly fine. But there's lots of gray area between public and private, and like, you know, where it might be okay to take pictures of people in the park, is it okay to take pictures of people in the club, you know? And so there's variance there on what people think is okay. And again, the bottom line is that if you're in doubt, you should be going to an institutional review board and asking them for their opinion. Yep.
Can we go back to the previous slide for a second? So it says individual test results should be kept confidential, and then records are made anonymous. So we're saying like we don't kind of put a name or a label on the results. Yeah.
So that's usually true. Like, so when I run studies, I usually don't even bother like writing down the person's name, for instance.
Okay.
I don't want to know it. You know, they just become participant 7, and then on all the records, you know, you have participant 7. And so this is about aggregating information before it goes out to the public. And this is about maintaining anonymous records in case they get stolen, basically, which does happen more than you would hope. Okay, a little bit about conducting experiments. So getting signed consent forms is important. Explaining the goal of the experiment in a way that people will understand is super important. You want to be very careful about the demand characteristics. So you don't want to tell people like, I'm expecting that you'll be much faster with the bubble cursor, because that's going to screw up your data. So there's some, you know, it's a thing you have to navigate, the difference between disclosing everything about a study up front and still avoiding biasing people. Answer any questions. During the experiment, stay neutral. Never indicate displeasure with users' performance. People screw that up all the time because it's so easy to be like, oh my gosh, you suck. During a user study, don't do it. It just stresses people out and it screws up your data. And then after the experiment, the big one is to debrief the users. So if there was anything you couldn't tell them in advance because you were worried it might bias your data in one way or another, now is the time that you need to tell them that, and then answer any questions that they have. Privacy and confidentiality are all about having control over the extent, timing, and circumstances of sharing information about yourself. And then there's lots of places where privacy has been violated, and we'll talk a little bit about a few of those. So there are a few horror stories in kind of the history of social psych experiments that we need to talk about, and that are supposed to scare you straight and have you not go out into the world and do these things. But the most famous, probably maybe tied for most famous, is the Milgram experiment. Anybody know anything about the Milgram experiment?
Is that the one where a subject is screaming on the door?
Yeah, that's the one. All right, so the notion here is that you bring 2 people into a room, and one of them is a participant, and one of them is a confidant who you are suggesting to the participant is a fellow participant. You flip a coin, and you have the person, your confidant, call the coin flip, and you make it so that they always become the person that goes in the box, okay? So the person that's part of your experiment goes in this other room, and then you and your participant sit here, and you tell the participant, we're doing an experiment on how well people learn and whether learning can be reinforced with electric shocks. And you give them a tiny little electric shock to kind of show them what the process is. And then you say, all right, we're going to have you teach foreign vocabulary words to this person. And every time they get one wrong, I want you to shock them. And we're going to keep cranking up the shock amount. And so the way the experiment was conducted, basically, was that you had to keep applying shocks, and the person on the other side would scream in pain and say, I have a heart condition, like, you're killing me. And, you know, they weren't actually being shocked at all. They were an actor working for the experimenter. But eventually, you kept ramping up the amount of shock that you were giving them. And eventually, the person on the other side bangs on the walls and screams in pain and then goes silent. Okay? And so the idea is that you're giving your participant the notion that they have now administered like a lethal electrocution to the other participant. And what they were really trying to test was, would this person do it? You know, this was a test about authority, so it had nothing to do with learning. It had nothing to do with, you know, vocabulary. It was about, would this person behave as the experimenter asked them to, or would they say, you know, screw you, I'm not going to kill this guy, I'm out. The ethics of the experiment on its surface are debatable, I think. Like, you could maybe run this experiment in an ethical way. The reason that it's held up as like the gold standard for how to screw up experimental design is that they forgot to debrief most of their people. And so they let people leave the experiment literally thinking they had murdered someone, and then just go out into the world and continue their lives. And they had reports of people that committed suicide after participating in the test, people who had like massive panic attacks, people who, you know, freaked out and like screwed up their lives just by participating in this thing. So don't do that. If you go and if you think, I've got this great idea for a user test, it involves electrocuting people, like, it's been covered, and don't do it. Second most infamous study of all time is the Stanford Prison Experiment. Anybody know anything about that? Okay, so the Stanford Prison Experiment was this study in 1971 where they brought in, go Stanford, brought in a bunch of people. They had them arrested and brought into a jail, and they flipped coins, and they determined that half of these people were going to be prison guards and the other half were going to be prisoners. And they wanted to just see what would happen. Like, the hypothesis was that the prison guards would start acting like prison guards and the prisoners would start acting like prisoners, even though their lot in life was determined just by a coin flip. Turns out it's true, by and large, that does happen. People kind of flipped out. And so over the course of like the week that this thing managed to stay intact, the prison guards went a little nuts and started just like literally beating the participants and humiliating them and putting them in unsanitary, unsafe, degrading positions. And the professor said, okay, because that was kind of what he was trying to study. And so he let this go on to an extent that people like really were psychologically traumatized by this whole thing. And I was going to show the YouTube video. If you're interested, I really recommend going and watching this. But I decided it was maybe slightly too graphic for this context. But really fucked up. Like, this study was a bad thing. And so go and learn a little bit more about this if you're curious. The question is, was it useful? Like, did we learn something about the human condition that we wouldn't have learned without this study? The Zimbrado says yes. Like, we learned something about how people work that we couldn't have learned without this experiment. Therefore, it was worth it. But really, was it ethical? Could we have gained this information through other means? Were there other ways we could have done this without so much trauma for the individuals involved? And it's an interesting question. It's a question that you can debate about. And the bottom line is that it's not up to you to decide. Like, this is one of those places where the Institutional Review Board has to be involved and has to be, you know, giving you some set guidelines about how this would work. And I guarantee you that if you decided today that you wanted to duplicate the Stanford Prison Experiment and you went to an IRB with your protocol, they might let you do it. Like, it's not on its surface a terrible idea, but they would almost certainly post somebody with you where they had like an ethicist from the IRB on hand to make sure that things didn't get out of control. Anybody know why the Stanford Prison Experiment ended? So it ended after 6 days instead of the planned 14. The professor's girlfriend, who was also one of his grad students, showed up. She was a psychology researcher and saw how ridiculous things were getting and pulled the plug on it. She's now a professor here at Berkeley and has been for 30 years. But, she kind of came in and pulled the plug and saved the day. All right, so those are the two like canonical horrible examples. There are many larger, smaller scale violations of this sort of thing, but those were the two that really led to like the formalization of IRBs and this whole kind of process of human subjects approval. On a much smaller, less catastrophic scale, we had something very recently that made a lot of news last summer. Anybody know what I'm thinking of?
This when Facebook was controlling the posts and seeing if like a majority of positive posts maybe were happy or majority of negative posts maybe were correct.
Indeed. So there was a Facebook emotional manipulation study that was run in 2012, and the results were published in summer of 14. And the gist of the study was that they took about 700,000 users, and they decided to purposely show half of them kind of more positive information from their friends, and half of them more negative information from their friends. And as part of this paper that they published, they acknowledged that they had not in any way obtained proper informed consent, although they did say that agreeing to Facebook's terms of service was sufficient. It's not. And they went out and they did this thing, and anyway, it sparked this rather furious debate between kind of very conservative human subjects ethicists and the kind of more practical liberal ethicists in this space. I got a little more involved in this story than I intended to. I made a bunch of news by posting a bunch of angry things and coming out with my like Berkeley PhD credentials and slamming Facebook in the news. Oops. But anyway, the point is that there's reason to debate whether or not this was appropriate. Like, was this different from like a standard A/B usability test? Should informed consent be obtained for standard, large-scale, massive A/B user tests? Should, is marketing inherently unethical? If you change Google search results to try to get people to buy more stuff, is that, skirting an ethical line, or is that okay? I have the privilege in my current job of being able to like sit every single participant that I have in a user study down and go through a proper informed consent process. But that's because I'm doing like really hands-on, qualitative, individual, one product at a time style user research. I understand that like if you're doing the sort of big data approach to user research, you have a different set of constraints. And so there is like very different opinions on this matter. I think that this crossed a line. Some people don't. And that's what you need to know about it. If you want to see my angry blog post, it's on Kanoma's blog at this point. You are welcome to go check it out. Anyway, if you want to learn more about this, which I do think is like really super important, we have an online training course that I really recommend everybody to go check out. They are more stoic about this issue than me. I'm more in the angry camp about this issue. So feel free to go there and learn some things. You can also read the Belmont report. And then you can also, 79 was when the Belmont report came out? Wow, late. And then you can also go and read like the current laws, which have actually evolved a little bit since the Belmont report days. Any questions on any of that? All right, there's a seminar finishing up right now up in the WAS that you may be interested in catching the second half of. Valkyrie asked me to advertise it. It's Chris Nussel talking about what are the best and worst user interfaces you've come across in science fiction. So that could be fun. It's up in the WAS right now. Go take their pizza, if nothing else. And on Thursday, we will talk about inferential statistics. See you Thursday.
Thank you.
Um,